I told Mum that Max just might bring her, and then she was like, go on, tell her to. I'll just turn around and say, she's 18, I'm retired. Like, that might be my friend. I feel like that would be my friend.
Why does Miss Mathis do that?
Maximus is calling everyone. I didn't do one piece of work in the whole semester.
Okay.
You're fat. Someone told me I didn't need to hand in the case studies, and then she turned around and was like, I need all of them. I was like, okay.
Limits and continuity is the area we're looking today. And we've done a little bit of this. Before, so the limit of x tends to a of some function equals p. What it actually means when in words, it means the limit as x of, limit of x fx as x approaches A. Is P. So often it's pretty simple, it's just a matter of substituting in. So like this one here, find the limit as x approaches 2 of 3x squared. Simply a matter of substituting the 2 into there and 3 times 2 squared, which is 3 times 4, and the limit then would be 12. But as we know, things are not always that simple. No, I'll show that. Someone's turned it off. So,
I can get on the table and turn it on.
I could get on the table and turn it on.
Yeah.
Probably just reach from the ground, to be honest. Not everyone's just tall as you, mate.
Oh, wait, for this issue. Don't worry about that.
Yeah, if you just like them stand there and you can't switch off.
You can go up there and do that. Marvellous. Alright. Now, we get into a bit of an issue when we have something like this. So this one here, for example,
True, make sure you have a study plan.
Oh, no. Were they here yesterday?
No.
Have they not been here for? They were here.
Yeah, we'll talk later.
First time this is all we're doing today.
It is.
Alright, so if we just follow what we did before, then the limit as x tends towards 2 of 2x squared minus 5x plus 2 over x minus 2 equals 2 times 2 squared minus 5 times 2 plus 2 all over 2 minus 2.
We're gonna have a 0 on the bottom.
So you get 0 over 0, which is undefined.
We should.
But if we have a look at a graph of this right, if we have a look at a graph of this, so 2x squared minus 5x plus 2 over x minus 2 So if we have a look at the graph of this,
It's a straight line.
when x is equal to 2, this line looks like it's going through y equals 3. So it's looking like here we're told that the limit's undefined, but when we look at the graph, we look at and we see that it looks like there is a limit. It looks like it's heading towards here. Now, it's just a matter of if we tried to find the y value when x is 2, it tells us that it's undefined. So the question is what's going on, because there certainly looks like there's a limit and it looks like it's heading towards 3. So what that means is that we actually have a hole in our graph.
Oh yeah.
So x equals 2, we have a point.
There's discontinuous.
So when x equals 2, thank you, when x equals 2, our y value is undefined. So what we have is a hole in the graph. We've got a circle. So we put a circle there, and the rest of the time the graph exists. So our graph, as I already mentioned, it's suggesting that a limit does exist and that the limit's 3. So which suggests a limit exists. Alright.
Wait, how do you know it's 3?
Well, when I'm looking at the graph here at x equals 2, I'll come up here. So it looks like as we head there, it's heading towards 3, and if we come down from below, it's heading towards 3. So it looks like the limit, but the graph, of course, is not continuous at x equals 2. Alright, so that's the title was Limits and Continuity. So in this case, it's not continuous at x equals 2 because when we put x equals 2 in, we got 0 over 0, so we couldn't get a defined answer. But when we look at the graph, it looks like when we head each way, we're heading towards y equals 3. So how do we get around it? Well, the short answer is we factorise first. so when we've got something like that, we need to factorise first. So, thus we factorise first.
So when you identify these classes, it was not going
Now, a bit of a hint as to what one of the factors is going to be lies with what's underneath x minus 2. And x minus 2 is in fact a factor, and the other one would be 2x minus 1. So to get to 2x squared, it's going to be 2x times x, and to get plus 2, you have to multiply by negative 1. If you want to check that you get negative 5, negative 4x and minus another 1. So they then cancel. So what we're doing is we're looking for then the limit as x tends towards 2 of 2x minus 1, and when we stick 2 in there,
Equals
it
3.
is 2 times 2 minus 1, which is 3. And of course this line, when we go back and look at the graph, so we have here 2x minus 1, which is a straight line. This is a straight line. Minus 1 here is our y-intercept, and if we go across 1, we go up 2, so the gradient's 2. So this line that we've got there is 2x minus 1, so this line here is 2x minus 1, and it's got that one spot in it that's undefined, so it's not continuous here. That's what it looks like. Alright, so things like this, so how we get around to find the limit is we factorise. Hopefully then we're going to get a cancelling, and whatever's left will then tell us what the limit is. So we can see on the graph there, we're heading towards 3. All right. Now you'll also notice that it's heading to both ends of the graph are heading to the same place. So if I start down here and go towards 2, we head to there. And if I start up here and head towards 2, I'm going down, and so I'm heading to the same place. All right, so for a limit to exist, each part of the graph's got to be heading to the same spot. All right, we can't have one part of the graph heading there and then another part heading to here. All right, so they're both heading to different places. So in this case, there wouldn't be.
So it has to have the same gradient, or
Not necessarily the same gradient. We'll get to what's next term, we'll get to what's called piecewise or hybrid functions. So they can be bits of, you can have bits that are in different domains, but they have to
Is it just more
join up.
the same?
So you can have something that goes like that, then that's okay. So for a limit, they've got to join up, got to be heading to the same spot. All right. I'll write that, what I just said, I'll write some words about that. Another example, and then we'll step on. So, note. so what I just talked about then. Limit exists at x equals a if the graph on both sides is heading to the same place. And then
You forgot the end of line.
What is something like?
Yeah.
is that what it's supposed to say? Yeah.
Yeah.
Alright, so this is sort of jumping ahead with this sort of function to what's called a piecewise or a hybrid function. We have the whole domain R split up into some bits. So in this particular one, when we excuse me, so when x is less than 1, the function we've got is x cubed, so that's 1 cubed is 1. And the cubic graph looks like that. And then the other part of the function, the other piece of the function, is when x is greater than or equal to 1, and then it's just 6. So you can see on here, on this one, when we come from this side, follow up the line, we're heading towards y equals 1, but on this side, we're heading to y equals 6, so there's no limit. At x equals 1, there's no limit because each part of the graph's head to a different spot, and quite clearly it's not continuous there either, a bit more obvious than the previous example. All right. Alright, so it doesn't have a limit.
Should there be a closing bracket after the x cubed if x equals
No.
x? Or is it, should there be like another squiggly line on the other side?
There should be a comma. That's what it should be. Right, so it doesn't have a limit at x equals 1 because the left-hand part heads to y equals 1, while the right hand side right-hand side heads to y equals 6. Alright, so there's no limit at x equals 1, and also it's discontinuous at x equals 1 as well, and that's pretty obvious. Alright. Alright, whereas the previous one, I think I've still got it up here, have I? Yeah, there it is. Whereas this previous one from the left-hand side was heading towards 3, and the right-hand side was heading towards 3 as well. But it was undefined at that point there, so it was discontinuous at x equals 2, but there was a limit at x equals 2. This one here, it's discontinuous, but also no limit. All right, mathematical way of writing that is this. Rub all of that off.
Yep.
Leave the last line.
So mathematically, this is how it's written. A function. All right, so for it to be continuous at x equals a, fx is defined at x equals a. In other words, f of a exists, and it exists if it's anything other than undefined. Here it's undefined, so in this case f of a or f of 2 doesn't exist. And the other thing is,
Is that a negative after that to the second?
Yes.
it's just a, yeah, it's just a dash. Would you prefer me to use some other symbol for my dot plot?
Just put it, click in front of it.
Little arrow.
Put an arrow.
Just do
An arrow? Like that? Is that better? All right, the other thing is that the limit is x tends, excuse me, at x tends to a of f of x also needs to equal f of a. All right, then, so I don't think what does that mean, but the one I just rubbed off, which goes like this, and that was 1, it satisfies this first one because at x equals 1, it's got a value there of 6. But what it doesn't satisfy is the second one, because this part is heading towards 1, this part is heading towards 6. So it has to be able to satisfy both of those things. And this one over here is not continuous because it doesn't it satisfies the second one. They're both heading to 3, but doesn't satisfy this first one, that x equals 2. It's undefined. All right, that's it. INL. And on the website is the last, well, all the lessons are all there on the website.